Okay, so here is a DC voltage source. The voltage is Vs and Rs is the voltage source internal resistance. These are the two accessible terminals. Now it's given when the open terminal voltage is measured, that's 50 millivolt. It's measured using a voltmeter that has an internal resistance of 10 mega ohms. And with a 15 mega ohms connected at the terminal here, when the voltage is measured again with the same voltmeter, the measured voltage is 48.75 millivolts. We need to find what is Vs, the voltage actually generated in the DC voltage source, and its internal resistance Rs. These two we need to find. So let's first consider the open circuit condition. When the voltmeter is used to measure the voltage, it is connected like this across the, so if I draw it here again, that is our source there, and this is the resistance here, so VSRS, and this is the terminal here. So when the voltmeter is connected, since this is not an ideal voltmeter, what happens is this has an internal resistance of 10 mega ohms. That means we are in effect allowing a 10 mega ohms resistance path for current flow through this. This is not infinity, this is through this path basically. So a current can flow. So that is Rs and this is Vs, and the voltage measured here is 50 millivolt. So we can apply voltage divider rule to see to write an equation basically. So 50 millivolt is the voltage across the, we can just say in effect there is a 10 mega ohms resistance. So across the 10 mega ohms resistance, the voltage is 50 millivolts. It should have been an infinite and open circuit, but it's not, because the voltmeter's internal resistance is 10 mega ohms. So it is essentially that 10 mega ohms is coming across which the voltage is measured basically in this case. So 50 millivolt is the result, and Rs plus, so voltage divide, if we apply voltage divide rule, what is the voltage drop across the 10 mega ohms resistance? That will be 10 plus Rs. So here Rs we are also assuming to be in mega ohms. We are not changing any of the units, so voltage millivolt is remaining in millivolt, and there will be a ratio of resistance, so that's okay. And here we have Vs, which is the actually generated DC voltage, times, since we are calculating the voltage drop across 10 mega ohms, it will be times 10. So that's there. So this can be written 500 plus 50 Rs is equal to 10 Vs. Equation 1 we can write that. Now in second scenario, when a 15 mega ohms resistance is connected across the, connected in the terminal basically, so we have now the circuit becomes like this. Now this is the voltage source Vs, this is Rs, and this here is the terminal, and instead of trying to measure the open circuit voltage, now we are actually applying a 15 mega ohms resistance. We are actually connecting a 15 mega ohm resistance, and across which we try to measure the voltage with the voltmeter basically. So this is the voltmeter, but it also has this internal resistance, which is if we draw like that, it sometimes it's drawn as a parallel, but what the basic thing is, this is allowing a path of 10 mega ohms, its internal resistance, so it's 10 mega ohms as well. So basically the perfect drawing is better if we draw it like this. So the drawing is better like that. So this is the voltmeters thing, and here is the meter there. So this is no branch for current flow, but there is a parallel branch which is 10 mega ohms, and the voltage that is now being measured by the voltmeter, by the meter here, will be the voltage drop across these two resistances parallel combination. So that will be the actual resistance here connected, not only the 15 mega ohms, because the voltmeter is also applying a 10 mega ohms parallel path with this resistance. So the combination is 15 times 10 divided by 15 plus 10, that is 6 mega ohms. That is the resistance now actually in effect. So now if we apply voltage divider rule again, that will be 48.75 now. 48.75 is equal to Vs divided by Rs plus 6 times 6 here, because the resistance is actually 6 not 15 because of the voltmeter resistance as I talked before. So 48.75 Rs plus, so that's 292.5 equals to, sorry, this one, and then equals to 6 Vs. So that's our equation 2. So if we look at equation 1 here and 2 here, what we can do, we can multiply 1 by 3 and then subtract 2, subtraction 1 by 3, 1 times 3 minus 2 times 5, that will cancel. So we are trying to cancel Vs basically. So when we multiply that by 3, it becomes 1500 150 Rs equals to 30 Vs, and when this second equation is multiplied by 5, it becomes 1462.5 plus 243.75 Rs equals to 30 Vs. So when we subtract, what happens is these two gets cancelled, and here we get minus 93.75 Rs plus 37.5 equals to 0, and then Rs becomes 0.4 mega ohms. So that's the internal resistance, 0.4 mega ohms or 400 kilo ohms. So that we get now. So now we can easily find the voltage drop as well, the voltage generated as well, and that will be, if we go back to equation 1, that probably will be better. 500 plus 50 Rs, so Vs over 10, 500 plus 50 Rs, so that's 500 plus 50 into 0.4, so that's 20 divided by 10, so that's 520 divided by 10, that's 52 millivolts. Sorry, millivolts, it will lowercase because it's milli. So Vs is 52 millivolts. That's the voltage generated by the DC voltage source.